A massive live event broadcast, requires miles of heavy cabling and thousands of pounds of gear. But the device, keeping that entire 4K signal from collapsing in on itself, it actually weighs less than a cup of coffee.
Yeah, it really is wild.
Right. Welcome to today's deep dive. We are pulling from a highly technical product spec page from HDTVSupply, and our mission is to decode the invisible magic making modern live broadcasting possible.
It is your shortcut to being well-informed on the unseen hardware that powers your screens.
Exactly. So let's unpack this right away because we really have to talk about this name.
Oh yeah, the name is quite a mouthful.
It is absurdly dense. The AJA FiDo-R-12G one-channel single-mode LC fiber to 12G SDI receiver. I mean, what is this FiDo-R-12V actually doing on a set?
Well, think of it as a translator that solves a fundamental physics problem, because in broadcast, you are usually pushing high-bandwidth 12G SDI video over copper cables.
Right, which are standard, but they have issues.
Exactly. Copper has severe limitations due to electrical resistance. So if you push a 12G signal too far over copper, the signal integrity just drops off a cliff.
So rather than fighting that electrical resistance, this box just bypasses it entirely.
Yeah, that's the core idea.
It takes a light signal coming in over a single-mode fiber optic cable using an LC connector and acts almost like a digital prism.
That is a great way to put it.
It translates those incoming photons back into the standard 12G SDI electrical voltage that the production gear actually needs.
That's the core mechanism, yes. By utilizing light instead of electricity for the long haul, it maintains that massive, dense video signal.
Even with all the complex SDI metadata like HDR.
Oh, yeah, absolutely. It pushes all of that over a staggering 10 kilometers.
Wait, 10 kilometers? That's what, over 6 miles?
6 miles, yeah.
You're saying it's taking an uncompressed 12 gigabit per second signal and pushing it 6 miles without dropping a single frame or losing color depth?
Zero loss. I mean, you can have cameras scattered all over a sprawling Olympic stadium.
Oh, yeah.
Or, a 500-acre golf course.
Yeah.
And you still feed every uncompressed shot back to a central production hub in real time.
See, I'm looking at the physical specs here, and this is where the math doesn't seem to add up for me.
How so?
Well, moving 12 gigs of data over 6 miles sounds like it requires a heavy-duty, rack-mounted server.
Right, you'd think so.
But this device is 4.6 inches long, less than an inch thick, and weighs just 0.4 pounds. It's like a digital marathon runner.
It is incredibly compact, and more importantly, it draws a maximum of only 2 watts of power.
That's exactly my point. A standard LED light bulb draws more than that.
Yeah, it's pretty incredible.
So how does a 2-watt device in a tiny enclosure survive a live production environment? You stick this behind an equipment rack in a hot broadcast truck in the middle of summer. How does it not just melt without a massive cooling fan?
The secret is actually in that 2-watt power draw itself. Because it uses such an incredibly low amount of electricity, it generates virtually no heat.
Oh, I see. So it doesn't need to cool down if it doesn't get hot in the first place.
Exactly. Combine that with solid-state engineering, meaning there are no moving parts to break or wear out, and you get incredible durability.
Makes sense.
That lack of thermal stress is exactly how it maintains a safe operating temperature range of 32 to 104 degrees Fahrenheit, or 0 to 40 Celsius.
So the low-profile enclosure isn't just about squeezing it onto a crowded camera rig. The physical and thermal design inherently makes it rugged.
Right. It's built for the uncomfortable realities of field work. When you're managing a live broadcast, reliability is everything.
You simply cannot afford for a receiver to fail mid-broadcast.
No, absolutely not.
Which brings us to the value proposition for the network engineers actually buying these.
Yeah, let's look at the numbers.
For about $1,025, you are getting a 10-kilometer latency-free fiber bridge that fits in the palm of your hand.
And they back it with a 5-year warranty, too, which in the fast-paced broadcast tech world is basically a lifetime.
It's a huge deal.
It fundamentally shifts how productions are scaled. Because when distance and signal degradation are no longer physical constraints, the architecture of a live broadcast completely opens up.
It really forces you to look at the underlying infrastructure of the digital world differently.
It really does.
And here's a final thought for you to mull over. We've been talking about sports and concerts today, but these same tiny zero-latency SDI to fiber converters are now being integrated into surgical robotics.
Oh, wow, that's fascinating.
Right. Doctors are relying on this exact broadcast tech to see uncompressed 4K video from inside a patient in real time, with absolutely zero lag.
That is incredible.
It makes you wonder, where else is this invisible entertainment tech quietly saving lives?
Definitely something to think about.